Sarah left Minneapolis heading east. Okay, let me draw a picture. Here's Minneapolis. There we go, east. 60 mphs. Her sister followed her on the same route. So here's Minneapolis, going the same route, leaving 2 hours later but driving at a faster rate. Okay, so what's governing both of these relationships is distance equals the rate times the time. Okay, so distance, rate, and time. The rate isn't a variable here because 60 is the rate for one person and 70 is the rate for the other person. That's something that we know. So let's make an equation for Sarah. The distance Sarah has traveled is 60 miles per hour times t, the number of hours that Sarah has traveled. And now let's try to make an equation for Sarah's sister. The distance Sarah's sister travels is, the rate is 70 miles per hour, but the time is a little bit different. The time for Sarah is going to be t plus 2. And let me double check this in my head here. T minus 2. Because, oh, man, I hate that. There we go. It's gone. Because if t is Sarah's, the time that Sarah has spent traveling, then the time that Sarah's sister has spent traveling is 2 hours less. So, like at time t equals 2, Sarah's sister has traveled 0, right? So that needs to be t minus 2, not t plus 2, like I was thinking. Okay, because 2 minus 2 gives us 0, and that makes sense of the word problem. Sarah's sister was leaving 2 hours later. Let's do another example here. If Sarah's been driving for 3 hours, then Sarah's sister should have driven just a total of 1 hour because they left 2 hours behind. So that's where 3 minus 2 gives us 1. So we have these two equations that are modeling the same variables, the distance and the time. Now if you plug the bottom equation in for d in the top equation, because that's what d is equal to, I'm going to try to cram it in here. We have something we can solve for t. That's the question. How long will it take for Sarah's sister to catch up? So distribute that 70. Subtract 60t from both sides. So we get 10t on the left side minus 140 equals 0. So let's kick that 140 to the other side by adding 140 to both sides. And then divide both sides by 10. So t is going to equal 14 hours. It takes 14 hours until the two distances are equal to each other. So probably d equals r times t is going to help with this next one. A small jet can fly 1,072 miles in 4 hours with a tailwind, but only 848 miles in 4 hours with a headwind. So the big thing here is that your rate is different depending on whether you have a tailwind, which helps you, or whether you have a headwind, which hurts you. Okay? So we need to find the speed of the jet in still air, as if there's no tailwind or as if there's no headwind. We have distance, we have time, but we don't have two different rates. So there's a rate, there's a speed of the jet in still air out there. We'll call that r, lowercase r. That's the speed of the jet in still air. With tailwind, we have r subtracted by, actually that'd be r plus w for the speed. Okay, because the wind is traveling at a certain miles per hour, and we're just assuming that the full, like 5 miles per hour that the wind is traveling at is boosting our speed at 5 miles per hour. So the wind is adding something to the speed in still air. And if we're traveling into the headwind, then r subtracted by w is our rate. That's our speed with headwind, because that's slowing us down. So we actually have enough information to start making some equations. The first one will be an equation dealing with tailwind. The distance was 1,072. The rate was r plus the speed of the tailwind. And the time was 4 hours. With the second equation, there's 848 miles. That's our distance. The rate now is r subtracted by the speed of the headwind. Because the headwind's slowing us down, it's making the speed smaller. That was, again, 4 hours. So we could distribute the 4 in both those equations to make it look a little easier on the eyes. And now you can use the elimination method to add the top equation by the bottom equation. These cancel out. 4r plus 4r makes 8r, and then we got 1,072 plus 848. That makes 1,920. So we just need to divide 8 from both sides. So we have the speed in still air. It's 240 miles per hour. You could plug that back in to find out what that wind speed is too, but we don't need that. No, it does. It does want that. Sorry, speed of the wind. So you just got to plug 240 in back in here for r, or into the other equation, either one. So we do that, 240 times 4, 1072 subtracted by 2, that result. And then we need to divide by 4. So you're going to get 28 miles per hour. 28 miles per hour for the speed of the wind if you plug in 240.